Welcome to WeakNet.Academy. I am your instructor, Douglas Bordeaux. In this video lesson, we're going to be performing a Wi-Fi penetration test against a dual-band 802.11 access point. We'll be using the ALFA AWUS1900 AC USB 3.0 Wi-Fi adapter in our virtualized Daemon Linux environment. I will be breaking this lesson up into 3 sections. The first section will include getting familiar with the actual Wi-Fi terms and technology, as well as getting familiar with the penetration test process and how we can do this properly. The second section will be setting up the actual hardware in Daemon Linux itself. And finally, the third section will be the actual penetration test where we attack our victim AP. So what is a dual band device? When we say dual band device, we're referring to Wi-Fi or wireless equipment which can operate in 2 frequency bands. What is a band? Well, a band is simply a set of continuous frequencies. In Wi-Fi, we kind of call those frequencies channels, but the channels aren't every single frequency in the band itself. They're actually just set frequencies, and for instance, the 2.4 gigahertz band, the frequencies are 5 megahertz apart. So you'll see that the first channel starts at 2.412 gigahertz, which is channel 1, and ends in channel 11, which is 2.462 gigahertz. And the 5 gigahertz band, the channels start at 36, and they go to 64, and then they stop, and then they start at 100 and go to 65. Now that's for the USA. The 5 gigahertz band channels are actually 10 megahertz apart. The 2.4 gigahertz band is the most commonly used band. The 5 gigahertz band is rather new and is a little bit less crowded. So again, a dual band Wi-Fi or wireless piece of equipment is going to operate in both of the bands, either with 2 radios simultaneously, or it's going to operate on either or, like you get to switch back and forth. So why would a networking equipment manufacturer want to choose dual band? Well, as I said before, the 2.4 gigahertz band is fairly crowded. It's been around for a long time. There's lots of technical gadgets like smart home gadgets and even kitchen appliances and things that are going to be transmitting on this band. So there's going to be a lot of noise, which means our signal between our actual Wi-Fi devices, like say an iPad, and our actual AP, when we're sitting on our couch just browsing the web, and say our AP is somewhere else in the house, because there's so much other noise and traffic on the 2.4 gigahertz spectrum, we might actually not get a clear signal from our iPad to the AP. So what they did was they implemented dual band, which is going to allow us to use 2 separate bands. If the 2.4 gigahertz band is too crowded in your home, you can actually switch it to the 5 gigahertz band. Not only do we get the added benefit of using a different frequency, one which may be clearer than the other for a signal strength, but the speeds increase as well. The 802.11g standard says that we can get up to 54 megabytes in speed. Now that's like in an absolute vacuum. That's like in a perfect scenario. That's something that you'll probably never see. The 802.11n standard brought us up to a theoretical 800 megabits per second. Now this, again, this is probably something you'll never see 800 megabits per second. That's why they put theoretical there. The 802.11n standard introduced the MIMO antenna operation technology, which means you can have multiple antennas transmitting and receiving to multiple clients. So say you have one antenna on the left side of your router and one on the right side of the router, and the signal coming from your iPad as you're sitting on your couch browsing the web is being deflected and refracted, and it's spreading all over the place, and it's hitting one antenna with a much stronger signal than the other antenna. This allows the Wi-Fi router to actually switch to the stronger antenna so you get a much clearer signal. So finally we get to the 5 gigahertz band. Now the 5 gigahertz band is on the 802.11 AC standard and offers us much, much faster speeds. As you can see, 2,167 megabits per second. So now let's dive right into the pen test hardware itself. Again, we're going to be using the ALFA AWUS1900. This ran me about $60 on Amazon. I have a link here inside of the slides itself, which you can click on if you want to go learn more about this product, but I did take a screenshot from that link here. As you can see, this device uses the Realtek RTL8814AU or RTL88XX-AU if you're familiar with the drivers for the Realtek chipsets themselves. The Wi-Fi standards, again, it is 802.11ac, ABGN. which is dual band, 2.4 gigahertz and 5 gigahertz. It has 4 antennas, as you can see. I'm not sure if 2 are for 2.4 and 2 are for 5, or if they're all for dual, because it says right here, dual band 5 dBi dipole antenna. So I'm guessing that they're for both. The way that the Wi-Fi or any wireless technology works is that the antenna just needs to be a ratio of the actual wavelength. Again, the device is a USB 3.0 device, and for operating system, we're going to be using Daemon Linux. Let's move on to the actual driver itself. Now, the driver in Daemon Linux, we're just going to be installing it with the Daemon App Store. It's super easy. All you have to do is start the Daemon App Store and click on the actual driver, click check out, and that's it. Wait like a couple of minutes. It's going to download the driver from the Aircrack-ng GitHub repository, compile the driver using DKMS, and then it's going to install it for us. So we're actually going to wait to plug in our Wi-Fi device until after we install the driver. So DKMS stands for Dynamic Kernel Module System, I think. And what it does is it's going to take all of the drivers that you have compiled or set into a kernel, and it's going to store them. And whenever you update your kernel, say you use apt-get dist upgrade or apt-get upgrade, and it pulls down a new version of your kernel, rather than having you actually recompile all of your kernel drivers and put them back into the new kernel every single time, the DKMS system is just going to do that for you. Okay, so let's move on to the actual target access point. For this, I'm going to be using a Linksys E2500. This is $30 on Amazon, and you can save $4 if you install the Honey application, as you can see here. I bought mine for about $40. I kind of got ripped off. I bought it at a Walmart physical store because I was in a jam, and I had some sort of weird issue with a 3D printer, and now I had an extra Wi-Fi router that I have laying around, so I'm going to use that as my target. I didn't know it at the time, but this is a dual band wireless N router, which is pretty awesome. It does 2.4 gigahertz and the 5 gigahertz bands. And we're going to be taking a look at and attacking both. All right, so let's now dive right into the pen test. Now again, this section is going to be covering how to actually perform the pen test thoroughly. And the first thing we need to understand is the scope of the pen test. The scope is going to allow us to clearly define what access points we should be attacking for our clients. One thing we could do is ask for a BSS-ID list. A BSS-ID is the MAC address of the actual access point. And if we have the MAC address, we know a MAC address is a very specific hardware address for a very specific radio, which it shouldn't technically be cloned, so that if we're attacking a specific MAC address, we know that we're attacking the specific piece of hardware owned by the client. We can also ask for an ESSID list, which is the name list. Say, for instance, the client has a mesh network or a network with a whole bunch of access points with the same exact name, so that you can roam around in the building and keep the same Wi-Fi connection, just because the access points have the same name. Are we going to be performing client attacks? Client attacks include using EPAMR or host APD, in which we create an evil twin and sometimes even attack the clients that attach to our evil twin. Or are we going to be performing de-authentication attacks, which will include denial of service? Now, the de-authentication attacks, if we do them efficiently, the denial of service is very minimal. It's almost negligible. It's just like the person just gets kicked off the Wi-Fi access point, and then their supplicant software inside of their Wi-Fi device just connects them automatically back to the access point if it's set up to do so, which most of them are usually set up to do so. Finally, we get into server attacks. Now, server attacks include attacking the actual appliances themselves. Say, for instance, there's a scenario in which we come on site and we're performing a Wi-Fi penetration test for our client, and we actually gain access to their network and their WPA2 passphrases. Should we try to access the hardware themselves, test for weak passwords, test for weak configurations, test for unpatched systems and things like that for the actual Wi-Fi hardware itself? Now, that's very important. You don't want to just do that for a client and they tell you that was out of scope, because that, as cybersecurity professionals, that'll make us look bad. And then finally, we have a site survey. The site survey is basically walking around the building, roaming around, looking to see where we can actually access the target APs from. Now, why is client attacks, server attacks, and site survey actually part of the Wi-Fi penetration test? Well, as cybersecurity professionals, our goal is actually to convey the actual risk, like prove the risk of having an insecure Wi-Fi access to your internal corporate network. And the best way to do this is to show somebody, hey, I can actually sit out in the parking lot and gain access to your network. So site surveys are in fact part of the pen test, and they should technically be part of the report. Now the report itself needs to be its own report. Again, if you're performing an entire penetration test for a client where you're doing social engineering, you're doing physical penetration testing, you're doing the network penetration testing, and then they also ask you for Wi-Fi penetration testing, each one of those should technically be considered its own separate penetration test. And in doing so, we actually deliver the best product to the client that we can actually give them. Okay, so now we're in our Daemon Linux virtualized environment. I'm going to open up a terminal, and I'm going to plug in my Wi-Fi device just to show that the driver is not installed. I'm going to click Connect to a virtual machine. I'm going to click my virtual machine here, make sure it's highlighted, click OK. The next thing I need to do is go up into the VM settings here, and I'm going to just simply ensure that I do have USB 3.0 set up, which I do. USB compatibility is 3.0. Hit cancel here. I'm going to type IWDev to list my devices. We're going to see that it is not in fact listed. I'm going to type dmessage, and we'll see that it is in fact plugged in, as we see here. I'm going to type LSUSB, and you should probably see it there as well. We do, right here. But we can't actually access it, and that's because we need to install the driver. And to do so, I've made this super easy for you. All you have to do is click on my little Daemon App Store, wait for this to initialize. What this is doing is, as you can see here, it's actually pulling the latest revision before actually running the software itself. So you get the updated App Store every single time you click on it. So I'm going to click on category here so that I can order these by alphabetical order. And this is the driver we want right here, the Aircrack-ng DKMS driver for the AWUS1900. I'm going to check this here and just simply hit checkout, and this will take a few minutes. Great, so as we can see, this has in fact been installed, RTL8812AU. I'm going to hit exit here. I'm going to unplug the Wi-Fi device and plug the Wi-Fi device back in. Now again, you could kind of skip that step if you just wait until now to plug the device in. I'm going to type dmessage, if I can spell it correctly. Great, we see that the device is here. Now one thing to note is that this naming convention kind of sucks. I'm going to do IWDev, and you'll see that this name here is kind of long. So I'm actually going to rename that. I'm going to go IP link set, paste in the name, type the word name, and I'm going to name mine WLAN0. Hit enter. Now if we hit IWDev, we can see that it is in fact renamed. Now, next thing I'm going to do is open up Cherry Tree so I can start taking notes here. Now we have this Wi-Fi node here. Now the two ESS IDs that I'm going to be attacking are victim Wi-Fi router -2 GHz and victim Wi-Fi router -5 GHz. Now these are the two ESS IDs. So now to do a little bit of reconnaissance, we need to find the access point, and we need to find these two radios. So to do so, I need to put this alpha adapter into monitor mode. The best way to do this is, first of all, use airmon-ng check kill. And what this command does is, this is going to kill off any processes that may interfere with our Wi-Fi penetration test by trying to control the Wi-Fi device. And I've noticed that in the past, some of these will actually change the device's mode. Right now, we can see that the mode is managed. And managed mode means that we can set our Wi-Fi adapter to associate with a specific network. We can set it to associate with a specific BSS ID. We can set it to a specific channel. Basically, it means we're managing the device. We're going to switch this to IWDev WLAN0 set type monitor. And what this is going to do is put our device into RFMon or monitor mode. We type IWDev now. Now monitor mode is in fact required to use an 802.11 protocol analyzer like AeroDump, or to inject packets using like AirReplay, or what we'll see today is HCX dump tool. So now let's just simply run AeroDump with --band G, and G means that we're going to be scanning just the 2.4 gigahertz band. We're going to be looking for this ESS ID specifically right here. whoops, I don't know the channel yet, so I'm going to put my device as WLAN 0. And as we can see, we found the device immediately. Here it is right here. I'm going to copy this. Ensure that I do have this typed out correctly. Switch this to a 5. Oopsie daisy. Okay, great. So now what we want to do is grab the BSS ID for this. We can see that this is WPA2 CCMP, and this is passphrase. This is not WPA2 Enterprise like this network right here. This is passphrase. So this means that this does have one password for everybody. It's an asymmetric key. So again, I want to copy this MAC address, which is the BSS ID. I'm going to throw this into my notes here. And so now what I want to do is CD into penetration test, CD into Wi-Fi, remove anything that's in here currently, because I use this kind of as a space for files. And now what I want to do is run arrow dump again, but this time we're going to lock on to our 2.4 gigahertz AP. And we noticed before that the channel was 1. BSS ID is this, and we provide WLAN 0, and we hit enter, and we see that this is now no longer channel hopping. We are at the 2.412 gigahertz, channel 1 with 2.4 gigahertz band. We can see the beacons coming in. We also see again that this is WPA2 PSK, which is an asymmetric key. And so finally we have found our target AP. So what I'm going to do is create a new subnode, and we're going to call this victim Wi-Fi router -2 gigahertz. I'm just going to paste this in here. I'm going to create another subnode. We're going to call this victim Wi-Fi router -5 gigahertz. Now, why didn't we see this ESS ID when we were scanning for the 2.4 gigahertz band? Well, that is because there are two completely separate frequency bands, or two separate frequencies. The radio can only listen on one frequency at a time. So now let's go ahead and try to find our second ESS ID by not specifying the channel, but we're going to change the band to A. And we're going to do WLAN 0. And this is going to scan the 5 gigahertz band for our router. And there it is, channel 161. So let's go ahead and copy the BSS ID for this radio. I'm going to put this over here. And what I'm going to do is set the channel to 161. We should also, yeah, that's right. And we're going to filter only traffic from my target BSS ID so that I can ensure that I'm only actually attacking the target AP. And look, we're definitely locked onto the channel. Again, we can see that this is also WPA2 passphrase, which is the asymmetric key, which means it's just one password for this entire network. And we can see all the traffic and stuff here. So I'm going to hit Control-C and stop this. I'm going to copy this information. I'm going to put this into this new subnode here, just like I did for the 2.4 gigahertz. And this way we just have output here to save in case I type clear on my terminal here. I can always go back here and reference this without actually having to set the mode or change anything or start the protocol analyzer again. Great, so now let's go ahead and try to perform an attack. One thing you may have noticed is that there weren't any clients for either one of these APs, which is kind of sad, which means we're going to have to perform a specialized attack for this, in which we're going to be using the HCX dump tool. I believe what this tool does is it listens on the frequency we set it to. It actually initiates the EAPOL messages. By EAPOL, we mean the four-way handshake for a WPA authentication. And in doing so, sometimes the AP can leak the pairwise master key ID, which is PMKID. And the HCX dump tool will capture that. And if we specify a file, we could dump it out into a file. So let's do HCX dump tool. --help, and we can see exactly how to use this application. It's actually a really nice application. I wish it had a few more features, but we're going to do the interface as WLAN 0. we will do C1 because we'll attack our 2.4 gigahertz AP first. Let me make this a little bit bigger here. Add a subnode. I'm going to call this PMKID. Make another subnode here. Call this one PMKID. Now you don't have to use cherry tree. This is just one way I organize data while doing a penetration test. Finally, I want to use --enable _ status equals 7. And I think that's it, actually. I'm just going to go ahead and enter, and we can see that I'm going to hit Control-C and stop this because we did, in fact, capture the PMKID. Now, the PMKID, as I said before, is leaked by the AP. It is a security flaw with the 802.11 authentication mechanism that's used by my AP. And now that we have this information, I want to store it to a file. So I'm going to do O, and I'm going to do victim Wi-Fi router -2 gigahertz dot pcap_ng. And this is going to store a PCAP next generation file that we're going to translate with TCP dump and then hopefully crack with our Aircrack-ng tool. I'm going to hit enter here. And once I see the PMKID from my router, which I do right here, I'm going to hit Control-C, as you see here, and it's going to terminate the application. So let's do ls/lah and see this in human readable. It's only 29K for this right here. Let's use TCP dump, R, and then the file, and then W for our output file, which we'll do again, just minus the ng. And finally, let's run Aircrack-ng against our new file here, just to see if we can, in fact, crack this. We can. I'm going to hit Control-C. So to do so, I'm going to do Aircrack-ng again. Yes, I'm going to start the application that hangs. The word list is going to be user share word list rocku. And then we're going to run it against this file right here. There we go. So finally, we're going to be attacking just this one right here. See, we say with PMKID. That means that we can, in fact, attack this. Now, this is an offline attack. Aircrack-ng is not going to go back out and attack the router again. It's just going to simply use the contents of the file that we had captured before and translated with TCP dump, and it's going to attempt to crack the passphrase. So this is number 4. So I'm just going to hit number 4 and hit enter, and we'll see this start going. And look at that, we cracked the password right away. The password's Cookie Monster. Great. So this was our first attack against the AP. We were able to successfully crack the passphrase, which is the asymmetric key, which means anyone can use this to attach to this network. And so finally, let's move into the 5 gigahertz band. So let me copy this information right here. I didn't grab any PMKID information from here, but I'm going to add another subnode. PSK cracked, Control-V, and I can now access this anytime I wish. Great, so I'm going to clear the screen here, and again we're going to go after our 5 gigahertz, and this time I'm going to attach to that network with my phone so that we can demonstrate a de-authentication attack. Let me turn on Wi-Fi with my phone. Great, now my phone is connected. What I'm going to do is run arrow_dump --right. We're going to call this output victim Wi-Fi router -5 gigahertz. And I'm going to listen on the channel. Let's go back here to get that information. It was channel 161. And I'm going to specify the BSS ID as the actual MAC address here. Just copy and paste this. And then we're going to pass the actual device itself and hit enter. And now we're actually writing this information here. We can instantly see my phone trying to communicate out to the internet. And what I'm going to do is de-authenticate this. So I'm going to break the screen up right here, use this little button right here, and I'm going to use the AirReplay application. And again, this is a denial of service. So you want to ensure that you do in fact own this network. That you do have this network within scope for your client to perform the penetration test. I'm going to just simply send 1, and we're going to do BSS ID, which I think is -A with this. Again, I wish they would just make these all the same. Copy this here, paste, and the client that we want to attack is this here. This is the MAC address of my phone. And then finally after that we want to put, I think, just the device name and also a -D. What the capital D is going to do is ensure that it's not going to check the access point first for its existence. It's actually just going to attack it right away. So we do have the radio locked on to channel 161. As we can see here, the beacons are flying by. So anything transmitted by AirPlay is going to be transmitted on this channel 161. Let me get this out of the way so it's not confusing us here. Make this a little bit easier to read. And hit enter, and we could see that the device did in fact get de-authenticated, but we didn't actually capture a handshake. Or maybe we did. Yeah, sorry. My phone is a little bit slow to respond. There, we did actually capture the handshake. My phone was just slow to actually reconnect. So now I'm going to hit Control-C here, LSLAH, and I want to show you something right here. This is the capture file. This is the file that we need to crack. Look how small this is. This is only 38K. This is because we completely locked onto our BSS ID right here. We locked onto the channel, and so this is a very precise attack against this AP. So now this is much easier because we don't have to translate this file, this cap file, into anything. We could just run Aircrack against this. So we learned in the last Aircrack-ng call that the word list argument is W instead of word list. User share word list. ROCU. And we're going to specify the 5 cap file. And look at that, we cracked it almost instantly in what, 4 seconds? That's great. So I'm going to copy this information here, and now we have all that we need so far for the initial part of the penetration test report. Go back in here. I'm going to add another subnode, PSK cracked. Paste this in here. Okay, so now that we own the PSK for the 2.4 gigahertz and the 5 gigahertz networks, we're able to connect to those networks. Now, depending on the scope of the Wi-Fi penetration test, we may have to connect to those networks to try to attack clients, see if we can move around within the network to different VLANs and other networks, or even attack the appliances themselves. So to connect to the Wi-Fi network, it's actually fairly quite simple. We use WPA passphrase. And this application is super easy. The SSID has a hyphen in it, so I'm going to surround it in double quotes. Victim Wi-Fi router hyphen 2 gigahertz. And then we put the password, cookie monster. And if we hit enter, we see this kind of output. Now we need to save this output to a file. So I'm going to use the T command, which spits the output to the terminal and to a file. And I'm going to throw this file into etc WPA supplicant. And I'm going to call this victim Wi-Fi router hyphen 2 gigahertz.conf. There. And now with this information, we use the WPA supplicant tool. Specify the configuration, which is etc WPA supplicant and victim Wi-Fi router, and then the device, which is WLAN 0. Let me move this cherry tree out of the background so we can better read this. And I'm going to hit enter, and what this is going to do, it's actually going to associate and authenticate with the network, but that's all. Great. So we are technically connected, but not really. So the next thing I'm going to do is get an IP address. And I'm going to use the dhclient command to do so. Great, now we're connected. We have this IP address here of 1.13 in the 192.168 network. And this is what gave us that. And because this is a SOHO network, I know that this is a Wi-Fi AP, like a small home office router. I know that this is also going to be the authenticator, it's going to be the appliance, it's going to be the DNS, the gateway, everything. So what I'm going to do is I'm going to copy this, and I'm going to open up a browser, and I'm going to browse to it, and we'll see that if this is in fact the appliance, and it is. and we can see that it's definitely there. So we are connected. We could start attacking this. We can use something like Medusa or THC Hydra against this to try to gain the admin password. We could scan for clients with Ettercap. WLAN0-234. There aren't any clients connected to it right now, as we saw before. Just type L, hit Control C. We can see that there's just one, and again, that's the actual network appliance itself. So we are in fact disconnected. I'm going to hit Control C here, and that wraps everything up. So now I've showed you how to attach the network once you've actually cracked the PSK. I've shown you two different methods for cracking the asymmetric key for a WPA2 enterprise network. One using no clients at all, which is the HCX dump tool, in which it initiates a four-way handshake but captures the pairwise master key ID out of the first message. And the second method was the de-authentication message, in which we sent the message out to my phone. My phone was knocked off the Wi-Fi network. My phone's kind of slow, so it took a second to get back on. Once it got back on, the EAPOL messages came through, which is the WPA2 four-way handshake. I was able to capture that with AeroDump and then crack that. So I hope you learned something from this video. If you did, if you liked the video, please consider hitting the like button. And if you want to see more, be kind, please subscribe. Thank you so much. Have a great day.